All right, today we're going to practice how to simplify square roots and how to estimate square roots. So first, let's talk about estimating square roots. But whenever we're talking about square roots, you really need to keep all the perfect squares kind of in mind. So let's just kind of write them across the top of our paper. So I know 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16, 5 squared is 25, 6 squared is 36, 7 squared is 49, 8 squared is 64, 9 squared is 81, 10 squared is 100, 11 squared is 121, and 12 squared is 144. And that's probably enough that you need to kind of keep in your head. Anything more than that, you can just kind of grab your calculator. But it's good to be able to recognize a perfect square. So now let's say we had something like the square root of 10. Well, I know that 10 is going to be between 9 and 16. So I know the square root of 10 is going to be somewhere between the square root of 9 and the square root of 16. Closer to the square root of 9, much closer to the square root of 9. Well, I know the square root of 9 is 3 and the square root of 16 is 4. So I know that the square root of 10 is going to be a little bit more than 3. I don't know exactly what. I'm just estimating at this point. But I know that it's going to be between 3 and 4, closer to 3. Let's take a look at another one. Let's say I said the square root of 30. Well, 30 is going to be between 25 and 36. So I know the square root of 30 is going to be between the square root of 25 and the square root of 36. I know that the square root of 25 is 5, and I know that the square root of 36 is 6. Now 30 is 5 more than 25, and then 6 more gets me to 36. So it's pretty much in the middle, a little bit closer to 5 than 6, but certainly between 5 and 6. So a little bit more than 5, really probably closer to 5.5. Now let's think about how do we simplify square roots. That's just estimating their values. If you wanted an exact value, you could just go to a calculator and plug in the square root of 10 or the square root of 30, and your calculator would give you the decimal equivalent. So now let's take a look if I wanted to just simplify a square root. So this here is estimating. But now let's talk about how do I simplify a square root. And there's a couple of different ways you can do this. I'm going to show you 2 ways. So let's just take the square root of 48, for instance. Now, once again, whenever you are dealing with square roots, it's good to keep these perfect squares in mind. So when you're simplifying a square root, you want to break down 48 into 2 multiples of 48, but you'd like one of those multiples to be one of these perfect squares. So sometimes I actually work backwards because I want it to be the biggest perfect square. So certainly it has to be smaller than 48 to be a factor. So I can just take my calculator and go 48 divided by 36. That's going to give me a decimal. 48 divided by 25. That's going to give me a decimal. 48 divided by 16 is going to give me 3. So I know that I can actually break this down into the square root of 16 times the square root of 3. 16 times 3 is 48. So I haven't changed this problem. I've just rewritten it in a different form. Well, I know that the square root of 16 is 4. So I can evaluate the square root of 16 and it becomes simply 4. I don't know what the square root of 3 is. That's not one of my perfect squares. So it cannot be simplified. So I'm just going to keep it like that. So the square root of 48 can be simplified down to 4 times the square root of 3. Now there's another method that I like, which is called the birthday cake method. And in that method, you're going to be working up this way. So I like to give myself some room. And you're going to divide 48 by the smallest prime number that you can think of. So usually 2, 3, 5, 7, and that's usually enough. 11 would be next, but let's see if we can kind of work with those. So I'm going to go with the smallest. So I know 48 is divisible by 2 because 48 is even. So I'm going to divide it by 2. So 2 goes into 4 twice. 2 goes into 8 4 times. I'm going to keep going. 24 is even, so I can go ahead and divide it by 2 again. 2 goes into 2 once. 2 goes into 4 twice. 12 is even. I can divide it by 2 again. 2 goes into 12 6 times. 6 is even. I can divide it by 2 again. Well, now I can't divide by 2 any longer, but now I can divide by 3. You know you're done when you get the number 1 on top. And the reason they call it the birthday cake method is it kind of looks like a birthday cake with the candle at the top. So now, what does this tell you? Well, because we're talking about square roots, we're looking for anything that I have 2 of. So I have 2 2s and 2 more 2s here. So if they have a friend, so these guys have friends and these guys have friends, they can go outside of the radical. So this 2 can go outside the radical. I've taken care of that one. And this other 2 can go outside the radical. Once you take them out of the radical, you only write them once. But this 3 here doesn't have any friends, so this 3 cannot come out of the radical. It has to stay underneath the radical. Well, 2 times 2 is 4, so this is 4 times the square root of 3. So you can see I get the same exact answer no matter which way I do it. Pick whichever way you are more comfortable with. Let's do another one. Let's do the square root of 128. We'll do something a little bit bigger. All right, so let's take a look at our perfect squares. Again, if I start at 100, if I say 128 divided by 100, it's going to give me a decimal, so I don't want that one. 128 divided by 81 will also give me a decimal. 128 divided by 64 will give me 2. So I can say, well, this is the same thing as the square root of 64 times the square root of 2. 64 times 2 is 128. Again, I haven't changed the problem, I've just rewritten it. But we know that the square root of 64 is 8, so I'm evaluating the square root of 64 as 8. But I don't know what the square root of 2 is because that's not a perfect square, so that's going to stay a radical. So the square root of 128 is 8 square root of 2. Let's do it using the birthday cake method. Again, I'm going to leave myself some room. I'm going to divide by either 2, 3, 5, 7. I'll start there. And it's even, so I can divide by 2. So that would be 64. I can divide by 2 again. That would be 32. I can divide by 2 again. That would be 16. I can divide by 2 again. That would be 8. I can divide by 2 again. That would be 4. I can divide by 2 again. And I can divide by 2 again. I know I'm done because I've got my number 1 at the top. So now I can take out 1 2, 2 2s, 3 2s, but I have 1 2 here that doesn't have anyone that I can group him with, so he has to stay in the underneath the radical. So I have 3 2s that I can take out of the radical. This one has to stay in. Remember, you're multiplying these guys together. So 2 times 2 is 4, times 2 is 8. So this would be 8 times the square root of 2, which is exactly what I got up here. So why don't you try it on the work below?